This is Tom Bizant's Mr. Numbers, and today's show, we're talking about ideas and what proves it, that it's real and it works, is using coins, money, because money is in the real world and we want real world learning here. And so what I'm going to do is I'm going to first show you how to add numbers on the number wheel with one digit and also with 2 and 3 digits, and also then back it up with money. Because kids love that and it makes sense to them and it makes their learning real for them. So you can see a number wheel, and there's actually 2 number wheels there, if you notice that. And what we're going to do, let's just add 2 and 6. Okay, this is old for some of you, but bear with me because I want to take you to coins to prove it. If not, if this is new to you, then this is a whole new world. Now, what happens is that line, 2, 6 line, if this one becomes 1 less and this one becomes 1 more, then it's the same. Do you see where that's real? You add 1, you subtract 1. I got 3 pennies and 2 pennies. Okay? Now, if the one with more gets 1 more and the one with 1 less gets 1 less, I still have 5 pennies. One with 1 less gets 1 less, and one with 1 more gets 1 more. All of a sudden I'm at 5, 0. That's basically what we're doing here. We're taking the 2 down to a 1, and then the 6 gets larger up to a 7. And that creates a parallel line. And then you do that again, and you make this 1 less and this 1 more, and that becomes 8 and 0. And our principle here is 0 is the hero. When you get to 0, it points you right to the answer. And we'll use a square for the answers today, okay? Those add up to 8. Now, you can work your way back down. 8 and nothing adds up to 8. 7 plus 1 adds up to 8. 6 plus 2 adds up to 8. 5 plus 3 also add up to 8, another parallel line. And then 4 is all by itself. Well, it's 1 less and it's 1 more. It's 1 more than 3 and it's 1 less than 5. So let's just circle that. Let's do a double circle with that. Because 4 and 4 are 8. 3 and 5 are 8. 2 and 6 are 8. 7 and 1 are 8. 8 and 0 are 8. And you have all the pairs of numbers that add up to 8 are right there. Let's just use that with coins. And again, we could do 6 pennies or we can do a nickel and a penny. And let's say you know that a nickel and a penny is 6. The nickels are really helpful for you in math to see that you don't have to do 4, 5 pennies. You can stop right there with a nickel. Here's you have 6 plus 2. You can just do it this way. Take one of those pennies from there and put it over here, and that becomes 7 plus 1. 7 plus 1 equals 8. And we'll prove it because we'll go to 8 and we'll put it up there, and 8, 0 equals 8. Well, duh, hopefully, kids will totally get that and accept that. And so you have 8. So then you can work your way back down and you can go, okay, so 7 plus 1 equals 8, and 6 plus 2 equals 8, and 5, see that? 5 plus 3 equals 8. And now what we have to do is we have to change our nickel 5 pennies. 5 pennies and 3 pennies. We just said our 8. And then if you put 1 over here, you have 4 and 4. 4 and 4 are also 8. And you've just proved that all of those equal 8. There is the make 8s grouping. Okay, and there they are. And if a number is circled, add it to itself. So 4 plus 4, 3 plus 5, 2 plus 6, 1 plus 7, 0 plus 8. And we have 9 up here. Oh, well, because let's look at that and realize that we have 7, 8, 9, 10. So this is 0 and 8 are 8, but it's also 10 and 8 are 10, 8 or 18. Well, then one more and one less than 10. One less than 10 is 9, and one more than 8 is 9. And so 9 and 9 are also 10, 8. And we could do that with coins too. See that? And take a look down on the bottom here. And it just shows you these and the reverse of all these are all adding up to 8 or 10, 8. When you do that 10, you can actually put a dime up here. So that can be 10 and 8. And then you have 10, 8 or 18 cents. Now, we were talking actually about just like 2 plus 3. So let's just do that. So we got 2 there, 3 there. Now, we have 2 plus 3, and so if we take 1 from the smaller number and put it on the bigger number, that moves that up to 4, and this moves up down to 1. Now we have 4 and 1. You may know it's 5, and you're proving that 2 and 3 are 5, and 4 and 1 are 5. We haven't proved it yet, so let's just do 1 less here and 1 more here. You switch it over, and so that moves there. And now, actually, we have, it's really neat because 5 plus 0, well, there's nothing up there. So 5 plus nothing equals 5. You've just proved that 2 plus 3 and 1 plus 4 and 0 plus 5 all equal 5. Now, yeah, that's all simple, but I want you to have the basics down because we're going to get bigger here. So look at this next one. Let's actually just put our lines in. Take a leap of faith and believe that, okay, 9 plus 6 is also going to add up to a number ending in 5. And 8 and 7 are going to end up in a number ending in 5. And we're going to prove it, actually, because this is actually 10. Oh, look at this. We have 10, 5. Now, you can talk about 15. But if you want to, you can do different things. You can put the dime up here, so you have 10 plus 5 is 10, 5, or 15 cents. Now, you could also put the dime over on the 1 over here. And you got a nickel here. And so you have 10, 5, 1 10 and 1 5. 10, 5 is 15 cents. So you have it that way. Now, if you shade this in, and we do the nickel and 5 pennies are also a dime. And it's really helpful. No kid are going to complain about learning that a nickel and 5 pennies are a dime. 5 pennies are a nickel and 2 nickels are a dime, and that's all really helpful information for them. We're just going to leave that because we're going to bring 1 penny here, and that takes us to 6. And then this was 10 minus 1 is 9. 9 plus 6, and we had 10, 5. We still have 10, 5. Now, if we put another one down here, this moves up to 7, and all of these move it there to 8, and 8 plus 7 is also 10, 5. So you know that 8 plus 7 is 10, 5, and you can go back and work your way back to 10. So 9 plus 6 We still have 15 pennies here, or the equivalent of that, 15 cents, 10, 5 cents. Another one here, here, we go to here, and this becomes our 10, 10, 5. Now, we can actually go the other way here. We take one of these up here. We can actually, let's put our 1 there then and put the dime outside. Now, then we have our 4. So our 4 goes here. Now, if the dime is outside, really, it's over here on 10. So now, this is really interesting because actually this dime out here, here it is 10.1 or 11 cents, and 4 are 15 cents or 10.5 cents. Now, if you actually put it over here, it doesn't make any difference whether it's 10.1 or 10.4. Both of them are 10.5. Do the same thing with, take our 1 and give it to this number, and now we have 2, 3. Okay, we still have the same number. We have 10, 11, 12, 13, 14, 15, or 10, 10, 1, 10, 2, 10, 3, 10, 4, 10, 5. So the 10, 5, we still have it there, and it doesn't make any difference whether this is 10, 2 plus 3 or 10, 3 plus 2. It all is the same amount. Now, if we actually wanted to add, let's add 10.2 plus 10.3. Oh, well, then we can put a second dime over here. And look at that, works out pretty well. Or we just put a dime on 2. However you want to do it. It's actually, as long as it makes sense to you, it works. Because it's money. And so if you actually want to do it, you do it this way. Put 2 that way. We got 2 dimes there. Can't argue with that. And if we want to do, say, 20, 210.2, or plus 110.3, or 210.3 plus 110.2, 10.2, then we have 3. 310.5. Okay, 3T5 or 35. It's we have to have an agreement on what we're going to use for terminology. You can really see that is like multiple ways. It doesn't make any difference whether it's a 1-digit number or a 2-digit number. You just do your second wheel. Now, if you also wanted to do, you can do another option. There are just so many options here because you're really playing with numbers. So you have 1 plus 2 in the dimes. This is dimes over here. And then you take 1 less here and 1 more there, and that makes your 3. So you can prove that it's 35 or 3.10.5 cents that you got there. Let's add 134 and 125. Okay. Now, if we're adding those, what we can do is we can just circle them. So 134, and this is our hundreds or dollars. This is our tens or dimes. And this is our ones or pennies. So we can actually just circle. 134 is $1, 3 dimes, and 4 pennies. Now, the second number is 1, and we circle it twice because it's the same number, and 2, and 5. All right, well, let's just start over here. And now you may know, and it's actually really fun to learn your sets, because 4 plus 5 equals 3 plus 6 equals 2 plus 7 equals 8 plus 1 equals 9, 0. Now, after you play with this a while, many kids really learn that, oh, 5, 4, that's in the nines row, or it's in the nines angle. If it's a 10 and a little bit less than a 10, tens are right across from each other. If it's a little bit less, oh yeah, it's a little bit less than a 10, it's a 9. You can jump all the way up there, just like that. All right. So we know actually that this is 9. You put a big 9 right there. All right. Now this is 2 plus 3. And from our other one, we know 2 plus 3, 1 plus 4, 0 plus 5. We know anything straight up and down is a 5. Anything straight across is a 10. So those are, it's really important. Teach the kids that. So we know that this is a 5. Okay. Now, this is 1 and 1. So that makes it really easy, because you take one of the ones up to 2 and you've taken it from the other one. So that becomes a 0, and you have a 2 there. And so you have your answer is 259. All right. Well, this works out really nice, because we can actually see. Let's just do the first problem on this. This is something I just pulled off the internet this morning. And 537. So we're just going to circle them. 537. Now, it doesn't make any difference that you don't have to keep the numbers together, because they all add up. Plus 132. A double number plus 2. Okay? So we add, and again, we just draw our line first. And we can go, some kids will go, oh, I know that's a 9, or it's a little less than a 10. Yep. All right. And again, we're even in this short, thing, we're running into the same things. There's our 9. And so that one is going to be a 9. And again, kids can do this mentally really fast, and they can just scribble it out, and they're not even doing things in their head. They can just actually do the lines and go, okay, 0, 9, 0 points to 9, 9 is the answer. That's how you do it. Okay. Now we do the same thing with 3 and 3. So 3 and 3 becomes 2 plus 2 equals 1 plus 5 equals 0 plus 6. And 0 points us right at 6. And our answer for that is 6. And what's really important is kids are learning bonds, number bonds, sets of numbers that add up to 6 here. 6 and 1, 5, 6 and 0, 5 and 1, 4 and 2, 3 and 3, all add up to 6. There's only 10 bonds. And even when you go 11, 12, you just do the 2 bonds, and the 1 bonds, 11 is just 10, 1. So in 10, 3, 13s are just 10 threes. It's just the other side of this. And so let's do our last one is 1 plus 5. And that's 0, 6, and boom. Okay. And again, we're 5 and a little more past, because clockwise is bigger numbers. So we have 6 there. Okay, whoops, I wanted to get that in color. We have 696, one more of these. And again, these are all carrying ones, actually. On this one set, 286. We can do this one here. 286 and 505. 505. Okay. Now, hopefully you're seeing, the patterns as we do these. There's only, now notice this is a little past 10. You might think it's going to end with a 1. You have 6 plus 5, 7 plus 4, 8 plus 3, 9 plus 2, and 10 plus 1. 10, 1 is the answer, okay? So 0 points to 1. Should do that in the other color here. That points to the 1. 8 plus 0. Oh, well, that's easy. We have to add 1. So we actually take this up to 9. So we'll just add 1 there. It doesn't make any difference whether you do it before or you find the answer and then you add the 1. You just have to add the 10 here because those are dimes there. And then we have, that didn't go past 10, so we don't have to add any here. So we have 2 plus 7, 1 plus 6, and 0 plus 7. And again, hopefully you can see, that there's the lines like that, 5, 6, 7. Yeah, you can almost feel the angle of the line tells you that this is a 7, and that's a 9, and that's a 1.
So we can see the 3 wheels can be place value. The left wheel could be $7, the middle wheel can be 9 dimes, and the right wheel can be 1 penny.
The last thing that I want to show you, and it basically is, this is a line, a circle of pennies, circle centered on the circle, and this is a center of dimes. That's the center of nickels. There's a center of dimes, and here's the center of quarters. So you can actually see, and over here you can maybe see this is quarters, pennies, dimes, nickels, pennies, lots of pennies because they're cheap to work with. Let's do pennies first. So you put one right in the top, one right in the middle of the bottom, and you want to have it kind of be centered on the line both ways. Then you just center this way, and you'll find that it's exactly 4. And if you're a little off on the lines, it might be a little less or a little more, but it's actually going to be really close. And it's actually a way to figure out how much money you have is how many circles you have, because each circle is a dime. You just created 10 pennies as a dime. Great. Now let's do dimes. Okay. So we have a dime on the very top and on the very bottom, and you can go to that way and to that way and to that way, and you can see actually that's going to fit there and that fits in there, and you can just see how that works. It's a great activity for kids to do, and even they just play with pennies. And when you're done and they've moved on, you can just cash all your math material in, and there's 10 quarters. And again, I might make those, I might change those wheels to be on the outside. That might be easier for kids rather than trying to find the center of the line. So that's a work in progress. It'll also mean you don't overlap circles like this too. Thanks for playing with this. I think money really motivates kids. I think they really have fun playing with physical things. It appeals to different learning structures. So if kids are visual, if they're kinesthetic, if they need concrete examples, and once they totally get it, that is all those parallel lines add to the same line, and it makes sense to them, then at some point you can stop doing that and just do the lines. And then pretty soon you almost look at the angle of the numbers and it's there for them. So it's a whole different way to play with math, but it is dealing with the very foundations, the very structure of how numbers work. And we're just dealing with one less and one more equals the same number. And that's basically what happens anytime you're doing a line across a circle. So it's really fun. And again, get a roll 50 dimes. So you do 5 circles and they're going to fit right in there. And you could actually have it be a project if somebody has a bunch of spare change, a whole jar of spare change, pennies, 50 pennies. So 5 circles of pennies are going to fit a roll of pennies. I think that's really fun. Nickels is $2, 40 nickels, 4 circles of nickels. So it all fits into number wheels. And it's really fun to play with that. So there's the rolls for pennies, nickels, dimes, quarters. I got a bunch of them here. Putting money into those can be a great, you could have a class bring their coins and have it be a party thing. Bring some coins and we'll add them up. Know that money is a fun way to learn math. And kids need to learn money. And why learn all your addition separately? Learning money and learning addition and learning number circles all reinforce each other. Enjoy that, and we'll see you next week.